Swahili and then Hindi. So it's the English and then the Swahili.
Well, we're happy to be here. Many things have taken place before this actual meeting, and I'd like to credit that to Mr. Mani. He doesn't know how much he's played a big role from last year. We started thinking about such things to happen over here, and fortunately we were able to work together and get things. So thank you so much, Dr. and Mr. Mani. For the participants, okay, for teachers, how many teachers do we have here from this area?
Okay, so we've identified that we could use pipes, we could use a canal, or we could transport it by vehicle either in cans or buckets. So what we need to do now is look at each one of those possible solutions and determine how we want to try to make that solution, and then we're going to compare the three solutions and decide which one is the best method.
Prototype to show you guys. So here's the lake. The other cup is the village.
Here's the village,
Okay.
lake, village.
And here's the pipe.
There's our piping system.
Ta-da!
Does it work? Does it work? Does water flow uphill?
So there's our first problem that we've run into, right? We've had this great idea, okay, let's go build a piping system, but we can already see, like, it's not going to work because the village is higher than the lake. So now we have to start thinking, we're into our evaluating our prototype, the Tatmani Sampuli Kifani. So this is the first problem that we run into, right? So how are we going to get the water to go to the village?
Alright, there we go. Alright, so in the last group, we identified the problem. So based on each problem that we have a solution. Depending on the solution, depends on how our robot looks. So the different designs that we're going to do. So in this section, we're designing. Alright, so we're going to build our robot, put together our parts, and make something beautiful. Okay? So
when you build a robot, the robot is not smart like you. The robot will only do what you say. So, for the robot to understand you, you have to give directions. So, input, in whichever form it takes, is the direction you give.
Sasa huu ndio ugomo wa hiyo robo kama should they take it up and see? Yeah,
But this one is special. That right here.
This. Just like that. And then take your 35. See now you can share your set.
Now.
Yeah, they do.
But right now, unless you've already started programming, you push one button and all it does is spin. Because you haven't given it any commands. So if I'm a robot, I can dance, dance, dance. But Kendra wants me to do something. So until she gives me commands, I'm just gonna dance. Kind of like with your students. If you don't tell your students what to do, they play, right? You give them direction because your students are good and they follow your directions. My students, sometimes they follow, sometimes not.
So this demonstration is just going to show us how we can use basic movements to have our robot either move forward, move backwards, make a left turn, or a right turn. So I'm the computer programming Robo Krista over here. So
Hello everyone, I am Krista.
So I'm going to tell Krista, Robo Krista, to take 3 steps forward at the speed of 5. Now I want Krista to make a right turn. Okay, now Krista's going to do a 180. And she's going to make 2 steps forward at the speed of 3. Okay, turn right. Okay.
First thing when talking to a machine, which is basically a computer, a robot's a computer, the first thing to understand how computers actually understand what we're saying to them. And they do that using a number system called binary. And that's really unfun to program unless you're a real computer person that wants to do that. The next step is we have what are called programming languages that we program in. Now, programming languages are very precise. If I fumble a word, you probably can figure out what I'm trying to say. But if you actually make a mistake when you're trying to give commands to a computer normally, that computer will not run. It won't do what it's supposed to do.
Alright, so now we told it to go forward at speed of 4. Now we need to tell it how long do you want it to go forward. Do you want it to go forward like this? Do you want it to go like that? How long do you want it to go? And so we can, if we hit delay,
That's it?
Okay, so right now,
You can have more than 15 speed.
No, 15 is today. Only 15. Alright, confirm. Alright, so now we need a delay. So same way. Gonna take it, grab it, cover it. This one. Grab it, cover it over it to make the connection.
It's too much?
Forward for less time, right? Smaller. Do you want to add anything else? You want to try a left turn? So this is a right turn. So that one is going like this. Do you want to try going like this? Alright, left turn. Alright, so if you scroll, you can use this one to scroll down a little bit. Alright, so we want to go to chips. There we go. So go straight. Okay, alright, we're ready? That one might end up like that might end up like that.
Mana ini nauko perbaiki dia kita punya. I demonstrated with mine that they changed the program. Ini kabis. Okay, so.
So you're probably past this lesson and you're testing on the grid right now, and that's fine. Please stay quiet. Chapter, we're going to introduce purpose programming, and we're going to go over the grid, as you see up here, and also a flow chart in which you will program your directions, and this is how it will look in the computer when you program the instructions that you see here in blue. Okay, Steve?
Okay. So some of you have already discovered that it's not always consistent the way the robot moves. Sometimes it turns left a little faster than it turns right. These are things we can accommodate in the program. We can fix that in the program. Things you need to be thinking about while you're programming. How far do you want the robot to move? So if we want the robot to move 4 squares, how many times does the tire have to turn to go 4 squares? Now, what we control in the programming is the motor's speed and how long it runs at that speed. We can run speed from 0, which is sitting still, to 15, which is just as fast as it'll go.
What that we have here will basically make your robot run continuously. So you're going to go straight and make a left turn like this. Like that's how your robot will move. If you wanted to stop, like say, if you wanted to stop, say at this square here, and then make the turn, you have to add a motor command that's just forward. You set both motors to 0, and then you put in a slide delay 0.2 seconds. So that now, if we add this in between here,
On railways, on the railway road, what we do, we use lava rocks, isn't it? And we put lava rocks, and then we put the piece of steel on top, and then we put the rail. So that's useful. Some people don't know that, but you know that. You can tell them that's helpful. Kwa hivyo hata ikilipuka, bado ina manufaa. Si ndio? Okay. So, so, and if you're talking about fetching water for a family, we talked about the river and other places. Those are also some teaching moments that you can get when you're using your robot to be able to communicate, in addition to bringing this into life. For the hard sciences, if you want to look at Newton's second law, force is equal to mass times acceleration, you can look at acceleration of the wheel, you can look at the mass of the robot, you can look at the power from the battery, you can all add those up and see what is going on. Conservation of momentum, you can use that with the mass and force and time, and momentum with the mass and velocity, and you look at them together, how they work together to be able to accomplish something. So you can do high physics, high math, high engineering, or very low. Either is what you do. Sounds good?
Here we go. 1 and 2. So it needs to go. Let's go.